Mother Nature has provided us with many food sources, among which rice is the most commonly grown food grain in the world. After harvesting the rice paddy, it is generally brought to a collection center from where it is taken forward for processing. Among the processing techniques, parboiling is one of the main adopted processes. Along with parboiling comes the problem of its effluent, which is high in pollutant load. When released untreated into the environment, it causes havoc to the aquatic ecology. The initial phase of our technology, therefore, involves the collection of the raw water coming from the mill in a holding tank for continual aeration processing. To accomplish this, either an above-ground tank is constructed with a centrally inclined slope with a concrete bottom and catwalks for viewing, or a large subground tank is constructed to hold the water of a 3 to 5 day production capacity for continuous aeration. The walls can either be coated with an epoxy or lined with a chemical-resistant tile, or as in one of our demo plants, a dismantleable tank lined with an HDP sheet as shown here. In these tanks, different modes of aeration will be provided along with the recirculation of the water to reduce the temperature, the COD and BOD, while simultaneously providing equalization. Before bringing the raw effluent to the tank, macrofiltration is provided to eliminate all the larger particles which may cause clogging. As the water enters the collection tank, the surface aeration begins. Recirculation using pumps and agitation is then provided, along with a stirrer that performs all at the same time. In the design, provisions are made for the foam. Now a batch test is performed to determine the chemical dosing requirements for each batch. The dosing is done either by gravity or with a dosing pump to complete the coagulation and flocculation process. Success of our chemical process show the colloids are distinctly separated and flocculated, as it is clearly visible during an operation done at one of our other project mills. Given time, the now agglomerated and heavier flocks will sink and settle on the bottom of the tank, or, conversely, we can make the flock float to the surface by using an effective micro-air bubble generator. Shown here is a prototype of a larger and more effective micro-bubbler that we are presently using in our flotation tanks. Now you can see the flocks floating to the surface from where it will be either skimmed off or overflowed into a sludge separator to be forwarded for dewatering. This can be done using a raised dewatering bed or a sludge pit for composting. Sludge cakes can be made available by either using a screw-type filter press as shown here, or a belt-driven automated filter press. After the sludge has been removed, using a single pump, the supernatant is being collected in an intermediate holding tank for further filtration. TSS has been removed and turbidity has been significantly reduced in the supernatant. In the pilot study, the supernatant was polished through a cross-flow continuous rotational system which works like a thickening process. Now, the polished supernatant flows into the main filtration section, where pressure filters of gravel, sand, and carbon are placed in a specific sequence. In the pilot study, we made the pressure filters with a 40% void. The filters consist of 1 gravel, 2 sand, and 2 carbon filters. This is followed by a 0.02 micron UF hollow fiber membrane and ends with a post-compacted carbon filter. The slight yellow color shown in the example is an organic pigment, and it's hard to absorb and totally destroy, but fortunately this color is only native to a few rice varieties around the world. The containers seen here show the raw water in the center. On the right is the water after the aeration, chemical treatment, and sludge removal has been performed. On the left is a beaker of water after filtration has been completed. One can distinctly see the difference after our technology has done the job. This is a trial to show that even difficult pigment colors can be removed using specialty resins. Using different specialty resins as per the client's request, the water quality that we're able to provide can even be up to deionized water standards.